So, welcome. What I today want to show is how, as an absolute amateur, you can do a little bit of electronics do-it-yourself stuff. That means soldering and having a little bit of fun with electronic components. First of all, I'm really also an amateur. I have no professional experience using this. As a child, I played a bit with electronics kits, but no soldering or anything. But the good thing is that nowadays you can buy this whole stuff for only a few bucks on eBay or Amazon or wherever you like, and get started really quickly. So, for the beginning, we would want to create one of those blinking circuits. You can get them off eBay pretty cheaply. I got mine for only €1 each. Shipping was even free. I will put a link in the video description where you can get those things, but there's a lot of sellers on eBay that sell these kinds of flashlight circuits. So basically the search words you're looking for are flashlight circuit production board, do-it-yourself kit or something similar. You'll find a lot of different options and a lot of different variants. So what do these kits actually contain? Let's open one of those bags. Put away these things for the moment and let's have a look. Okay. First of all, there's the PCB, a little board with all the soldering pads where you will mount your electronic components on one side and put the leads through the holes and solder them onto those pads. Also we get two nice LEDs. They're probably blue, although you can't tell. They're transparent plastic. You also get two transistors, which are sort of like electronic switches that actually do the blinking, turning on and off of the LEDs. And to make this actually work, you also need two capacitors. These are electrolytic capacitors. We'll take a closer look at them in a moment. And you need a couple of resistors. These are those tiny things here, which are color-coded and they have different values. Those components up here are active components, the LEDs and the transistors. Those here are passive components, which means these are sort of like switches, or they do something, and these are more like passive things. The polarity on the capacitors and the transistors and the LED is quite important. We will see that when we will assemble this. This kit also comes with a lead of jumper cables that you can put into a breadboard like this here, but we won't use that today. We'll make it a bit simpler. I took one of those 9-volt plugs here, which you can also get for a few cents on eBay, and we will solder that to this, and we can just use a simple 9-volt block battery to attach this and drive the whole circuit. Okay, so we'll put this aside. The question now is, what do we need to do here? We take a look at the PCB and we see some symbols on here. So, for example, on the corners here you see the symbol for a diode, which is where the LEDs will go. And diodes have actually two different sides. One is called the anode, the other one is called the cathode. The cathode is always minus, so negative, and the anode is positive, so it matters in which direction you put them in on the board. You can always see at an LED the cathode on the side with a flat spot. So let's take a look. Not sure if you can see this, but here on this side is a flat spot, and it's also marked here on the board. So basically you can put the LED in here just like this, put them through the hole, and bend the leads a bit outward so that it won't fall out. Okay. We could start soldering now, but let's first take a look at what soldering actually means, what we need for that. So I bought a very cheap soldering iron on Amazon quite a few months ago when I started doing this, and it's really cheap. It was, I think, something below 20 euros. And what you get for this is first the soldering iron like this, which is very simple enough. It has a temperature dial, and you should use something around 250 or maybe up to 300 degrees Celsius depending on the solder that you're using. You have some kind of tools for which you can use to scrape off excess solder or do other things, poke holes and stuff, etc. Some hooks. And also we need some solder, obviously. It also comes with this tube of solder, so it's two different kinds of solder. This one here I bought because it had very good recommendations on Amazon, and I think it works pretty fine, and it's plenty for the next few years, I guess, of my soldering. You also get some pincers and this thing here, which you can use to desolder. If you made a mistake, you can actually heat up the solder and suck it out with this kind of syringe thing. But all of this we don't need at the moment. The only thing that you probably need is this, which is a stand for the soldering iron with a little sponge here, which you can put water in, so you can clean off the tip of your soldering iron. We won't be using that now as well, because I also have a thing like this monster here, which is called a third hand. You can clip in your PCB board here, put down your soldering iron here, and use the magnifying lens as well. I will only use for today this place to put the soldering iron, and I will use the sponge to clean off my soldering iron. So I put this to the side here so you can see better what I'm doing here. So first of all, we'll plug in the soldering iron and wait for it to heat up. So it'll take a couple of minutes and we can explain a bit more what we are doing here. Okay, so maybe we should talk a bit about the resistors. We have two different kinds of resistors. They are marked here in the rectangular symbols. One is 510, which means that here the 510 ohm resistors are supposed to go, and this says 33K, which means 33 kilo ohm resistors should go here. So the question is, how do we figure out which resistor is which? Two options we have. First is to go online and take a color table for resistor decoding, and we can take a look. This resistor here, very hard to see, has 4 bands, orange, orange, orange and gold, which means first band 3, 3, and the third band is also 3. The multiplier should be 1 kilo ohm, so you have basically 333 times 1 kilo ohm, which should be 300. Okay, we have a 4-band code and 5-band code, so basically this column doesn't matter. So we have 33 times 1 kilo ohm makes the 33 kilo ohms. So basically the orange ones are the 33 kilo ohm versions, and this one should be the 510 ohm. Let's see, this is hard to make out. It's green, brown and brown, I would say. Green is 5, brown is 1, and the multiplier is 10 ohms, so you get 51 times 10 is 510 ohms. Second thing that you can try is to get a multimeter. The multimeter can measure current or a resistance or voltage. And this is also a very cheap one from Amazon, and it's good enough for what we are doing here. And I put it into measuring ohms, and you can just simply take the probes and put them up against the two leads here. We should see that we get something like 500 ohms here, which is okay. It should be 510 ohms, but of course no resistor is perfect, and neither is this cheap multimeter. But you see this is probably the 510 ohms, and you can put it up to this resistor and you see it's 32.5 kilo ohms. It should be 33 kilo ohms, also close enough. Okay, so we see that this works out well. You can also check your battery if it's still good, because mine actually just expired. So let's see. Here's the plus, here's the minus. Let's put the red, as always, positive, and the negative lead here. And it says it has 6 volts. Okay, so this will be probably not a very good battery. It should read 9 volts, so after we solder it, we probably need to get another battery, otherwise it won't work very well. But maybe we're lucky, and it still works. If the voltage is too low in these kinds of circuits, you will get very weird effects. For example, only one LED lighting up, or both at the same time, because the circuit won't work properly with a depleted battery. Okay, so let's see. The soldering iron should be hot. Is it? Yeah, it's 275 degrees supposedly. So we can basically start by trying to solder this little body here. Let's take a bit of solder, and well, my soldering technique is not very good. I'll link to some good soldering introductions in the video description later. Just hold both parts next to the lead and wait for the solder to actually melt. Yes, and it will hopefully properly stick to the pad and the lead. It's also where the third hand usually comes in pretty handy, but for today we will skip that. Yeah, that looks okay-ish. We'll also have to find some pincers in a moment, or some cutters actually, some wire cutters, because we have to cut off the leads after the first few soldered components. So let's take the second LED and solder this as well. So here we are again. I couldn't find my better pincers or cutters, but I have these very crappy ones, which will do for the moment. We just try to cut everything as flush as possible so that it doesn't stick out. Here we go. Okay, this is a bit crappy, but it should work. Okay, next up, we will probably wire the resistors. So we said orange, orange, orange is the 33K ones, so we put that aside. We first start with the 510 ohms. It doesn't matter which way you put them in. Resistors aren't sensitive to polarization. They don't care about that. So just put them in here. Bend the wires right next to the resistor like this. Poke them through the hole. And on the other side, bend them a bit outward again, so they don't fall through the hole. Okay. Let's try soldering this one. The fumes here are actually from the flux in the solder, which helps. Oh, come on. Which helps with the flow of the solder to the pad. Okay, I sort of failed on this one. Let's try again. Okay, got it. Actually, I think for the next video I will definitely use the third hand because it's so much easier. Let's check this. Yeah, it looks not very nice, but with a bit of luck it will work. Most important thing to say about soldering is you have to try and get better, and you will get better definitely. So these things are actually great to get a little bit of practice and get better. So you will see a lot of people on YouTube which are much better than me at this. But this is also my first time recording this, and it's completely unscripted, so I hope it turns out okay and you will learn something. Now the next two resistors. Also, you can always take as long as you want. I'm a bit in a hurry here, of course, because I don't want to make the video too long. I might cut out a few segments of it getting too long, but I also want to show everything for the beginners. So 4 more legs. Let's trim them. And now we will take the transistors, I think. So the transistors will have a flat side and a rounded side, and you will see this also on the PCB board. And it actually does matter quite a lot which way you put them in. You can look up transistors on Wikipedia or something if you want to know more about how they work. They are basically just a tiny little electronic switch, or also an amplifier if you want to use them as an amplifier. In this case we use them basically as a switch. So let's solder this one. When you try this and in the end your circuit doesn't work, you can also use the multimeter to debug basically what went wrong. You can test if the voltage or the resistance or the current are correct at any given point. A lot of the do-it-yourself circuitry boards come with troubleshooting guides which say, yeah, this resistor you should measure this and that voltage or this and that current. It's quite useful if you made a mistake, some solder joint is not properly working or something like that, or maybe you destroyed an IC or something by heating it up too much while soldering. This will happen most probably with the projects that you start with. And I am looking forward to if this actually will work. Bend it a little. Or if we screwed up already, but we'll find out only in the end. Okay, next transistor is up. Just like the other one. Transistors used to be very heat sensitive back in the day. The modern ones are a bit more forgiving, but don't heat them up too much anyway, which is the case for all ICs or all components like that. And with larger ICs you can always use sockets and solder them first and then just put the IC in a socket, which makes it more reliable. You can also replace the ICs easier if they break down at some point in your experiments. Okay, so now we've got the transistors, the LEDs and the resistors. Only thing left, apart from the power connection, are these electrolytic capacitors. Well, they have on one side a stripe with a minus sign, so that's the negative lead. And there's also always a plus and a negative sign usually on the PCB board. So you just put them in the correct polarity. Also the plus lead is always the longer one and the minus lead is always the shorter one. But you can't see that anymore after clipping them off, obviously. So we take the first one, and I think I'll put in the other one as well. Mind the polarity. We'll just solder them all at once. And the moment of truth is coming nearer. Does it work, or did we fail? I'm now taking all bets. Let's see, yeah, looks not good, but probably works. Cut off those leads. Yeah, it's pretty ugly. Also, you must make sure that no solder goes across the pads, or otherwise you will have a short circuit, which is also not very nice. Okay, last thing to do is to solder these leads here. VCC is the positive side, GND is ground or the negative side. Black is negative, red is positive. It's usually easier if you put some solder on the wires first, but I'm lazy and I won't do that today. I will just put a big blob of solder on this pad here. Big fat blob. So, seems to stick. Let's do the same for the ground. Hopefully we left the ground open. Yes, there's still some place for the ground. Okay, you won't be able to see this probably, but also putting a big fat blob of solder here. Got that. And now I will turn off the solder iron so that we don't burn ourselves by accident. Okay, we are done. Everything is finished. Let's see if this actually works. So you can't really put this on the wrong way because of the shape of the contacts. So let's see. And surprise, surprise, we seem to have done a correct job. The flip-flop is actually working and it's very nicely blinking. You can exchange the resistors for different values and get a faster blinking flip-flop or a slower blinking one. And yeah, but this actually pretty much works. Okay, so I will put some links in the description where you can buy all of this stuff. But as you saw, these things are pretty cheap and you can solder a couple of them in the evening and practice your soldering skills. It's a very nice thing for beginners, and you can spend like less than 50 euros, probably even less than 30 euros to get started with this whole thing and have a lot of fun and a lot of options later on. And in the next videos we will gradually do more complex stuff. Okay, so my phone actually ran out of memory right there. So for the next video I definitely know I need something bigger to record on. Anyway, what I wanted to say was we'll do more complex projects, most of them which I haven't done before, so we will see some failures and learn some lessons, but that's actually why we're here, and it's supposed to be fun. And so far I want to thank you for watching, hope to see you soon, and yeah, share this video, like it if you like it, and yeah, see you next time.